answer all your questions, kind of get those, because the way probability is, you kind of need to do a problem and you think you did it right, but you want an immediate feedback. So today I'll walk around and give you that immediate, on the site feedback so you can feel like, oh yeah, I've got this, okay? Because it really does take just kind of doing it and reading it and getting that process down. Okay, so on this page 4, y'all had done this one yesterday. So you are picking from two separate bags. So you have two events. So if you have two events happening, then you've got something in that first event that has to occur, and, which is multiplication, something in that second bag to occur. So that's one event happening times the other event happening, so they both are happening at the same time. So therefore, it was 1/5 times 1/6, which is 1/30. Okay? The second one, having both of them be letter L's, it's the same thing. The first event, picking from bag 1, and you want it to be an L, that's 1/5, and you want the second bag to be an L, which is 1/6. So there's that 1/30 again. Yes? Okay, so I've gotten questions about this word both today. Okay, and it seems like yesterday when I said on the notes that this union is on the bottom of this. Okay, so I said this union was or, and then here we did either, or, and both. Okay, so that references picking from, you know, say you have, you're picking from, uh, you have one car, and you want to see that this one car, you know, is it red, or does it have a spoiler? You know, and then this would be that one event, picking one vehicle, and that one vehicle having both a red trait and a spoiler trait. That's not, that's a different kind of both. I mean, so I'm thinking, when I did the notes yesterday, I've had that question several times, so I should have done that because everybody's been taking that so literally. Because when we do these, it is two separate events. So I want this event to contain a letter L and this event to contain a letter L. What you're referencing is what's the probability that they both contain an L. So I would have to figure out what's the chance that, well, no, there would have to be, I don't know how to explain the difference between that, except for to say these are from two separate bags, and that other one is if you're just like picking one item. So, therefore, I think I should maybe change that in my notes from yesterday, since I've had some confusion there, because some people are taking that literally on that both. Okay, so the intent of that, let me just say this one more time. The intent of that was because I've had some people in the past, if I say what's the probability that it is red or spoiler, that it is a red car or it has a spoiler, people just pick this section plus this section. They don't also consider the ones that have that are red and a spoiler. That's why I had said or both, because you can have cars that are only red, only have a spoiler, or are red cars with a spoiler. So that's where that both comes into play. All right, moving on, because I'm obviously beating a dead horse there. So on this, we've got at least one of the letters is a vowel. So you need to remember that when we have this at least one situation, it's too much to find all the probabilities, all the possible combinations that you have at least one of the vowels from the first, one vowel from the first one vowel from the second one, or two or both of them being vowels. So that's too many combinations. The best is to say 1 minus none of the bags giving you a vowel. 1 minus the probability of none. And so that's 1 minus probability. The first bag is not a vowel, and the second bag is not a vowel. So that's 1 minus 2/5 times 4/6. then that reduces over to 11/15. Or you could do the decimals on these as well. Okay. All right. So questions on that. Okay. I mean, you may follow what I'm doing, but then you'll get to practice that today, and I'll walk around giving you lots of assistance and support on that. Let's go down and let's do these ones down here. Okay, so what is the probability of getting a B, getting something in the B circle? What is it? It is 0.4 because it's the entire B circle, not just the 0.3, but also the 0.1. So the entire B circle is the 0.4. All right, so what is this or? Okay, union meaning or. What part of that picture does that encompass? Okay, good. Everything in this circular section. Okay, the A only, the B only, and the both A and B. See, so anyway. So I can do this one of two ways. I can say, okay, it's the 0.4 plus the 0.1 plus the 0.3. So I'm going to add that all up, and I see that that means 80% of the information is in the circle. Which, by the way, what part is not in the circle if 80% is in the circle? 0.2, because it has to be a total of 100%. All right, part C. Find A and B's, and then what's that little C mean? The complement. So once you find the A and the B section, okay, so this is the and. So what is the A and B section? Okay, good. So A and B is 0.1. But I want the complement of that. Okay, so the complement would be 1 minus 0.1. That's everything else, so that's 0.9. All right. Now, this last one is actually quite involved. I haven't stopped because these are not necessarily independent events. So I haven't stopped to do this one to demonstrate it algebraically. I think this one is most easily demonstrated with shading of the picture. Okay? So if you just have one picture or one writing utensil, then I would say maybe do the stripes for the first shading we're going to do and then squiggles for the second shading we're going to do. So I'm going to do two different colors though. So the first color that I'm going to shade is going to be the complement of A. All right, so where is the complement of A? Everything outside of A. Okay, so all of this section that is not A. Complement of A. All of this section that is not A. Okay, so there's your A complement. And so now I want to shade the section that is the complement to B. Okay, so maybe do this with squiggles if you just have a pencil. I'm going to do mine with the color green. So I'm going to shade the complement to B. So that's everything that is not B. Okay, so there's the not B section. All right, so what is it that I want? Find, what's the question asking for? What is that little symbol in the middle? And. So what part is that of a picture? It is not the 0.1. It is the and is the intersection. I want the part that is shaded blue and is shaded green. So where is the part that is shaded blue and shaded green? Yes, this 0.2 is all of the outside section that is shaded both green and blue. So that's the intersection of those two complements. All right. Do you see how that's quite a bit different of an answer than part C? So where that little complement is located it makes a big difference, okay? So you just kind of have to pay attention to where that is. All right. So our assignment is going to be questions really more like these ones here in number 5. So let's take a look at these. You're going to get 5 multiple choice questions. And you have 4 possible answers for each question. Okay, so we want to know then what's the probability that you get none of those 5 correct, or all of those 5 correct, or so on. So let's kind of say what's happening for one question. Just on one question, what's the probability of getting a correct answer? Okay, 1/4. What's the probability if you just randomly guess on getting one question wrong? 3/4. Okay, but this problem is about 5 questions. So not just about 1, but 5. Get none of the questions correct. That means the first one is wrong, and the second one is wrong, and the third one is wrong, and the fourth one is wrong, and the fifth one is wrong. So I have 5 events. Each one of those questions is its own event. Now, what are the probabilities that go for them? Yes, they are all 3/4. So whatever 3/4 to the 5th power is, that's what your answer would be. Okay, so try B. Probability you get all the questions correct. All 5 of them are correct. Okay, so just 1/4 to the 5th power. Now, what is a key phrase I want you to pay attention to on question C? That you get at least one of the questions wrong. At least one is the key that I'm teaching you to hone in on. At least one means that 1 is wrong, or 2 are wrong, or 3 are wrong, or 4 are wrong, or 5 are wrong, and those could be all different combinations. Okay? So 1 or 2, 3, 4, or 5. Everything except what? Got none of them wrong. I want at least one. I want everything except all possible combinations except that one time when none of them are wrong. So the best way to compute this is all the possible combinations, that's 100% there, except the probability that none of them are wrong. Okay? What does it mean if none of the 5 are wrong? They are all what? Correct. So 1 minus what we just got a second ago, 1/4 to the 5th power, and that would be your answer. Okay? All right, this last one, get your first incorrect answer on the 4th question. Okay, so we've got 5 events that we are defining. Okay, the first incorrect one is that 4th. So the first wrong one is there, the 4th. So they're defining what happens in front of that. What then happens to the first, second, and third question? Okay, they're telling you you got those first 3 correct, and you got that 4th one wrong, and here's something that's important. This can be anything, so I don't care. They are not telling me what has to happen on this, so don't even tell me. You could put a whole number 1 there, something happens there. It's right or wrong, I don't care. So you just don't even need to worry about what happens after. They only define the order of what happens through the 4th question. Okay, and then whatever that answer is. All right, so now that we've finished practicing those, on your assignment, we are not going to have time to do this law of large numbers, which is the only song of that I have so far. But we'll do it later, maybe tomorrow after the quiz. I don't know. If not, we'll throw it in after Thanksgiving. And I want us to omit page 7 for now. Okay. Omit page 7 for now. And so your assignment today is going to be pages 8 through 11, because 11 is the warm-up. I'm going to do this first problem with you, and then I'm going to walk around the whole class period to show you, you can ask me quick questions on, did I do this right? Is this how you do this? And all that kind of stuff. So you'll be able to, I have had quite a few people finish 8 through 10 for sure, and several have finished all the way through the 11, okay? So it is possible if you kind of get the hang of it. So let's do this first one. Here we go. A consumer organization estimates that over a 1-year period, 17% of cars will need to be repaired once. 7% will need to be repaired twice, and these are exactly twice, not at least. So, and then 4% will need to be repaired 3 or more times. So exactly once is 17%, exactly twice is 7%, and 3 or more times to get repaired is 4%. All right. So that's all the repairs. So the first question is, now we are just picking one single car. So this is one event. Okay, one event. Pick one car and tell me what's the probability that it needs no repairs. So if it needs no repairs, then it's what portion of our information? The other part that I haven't told you. All I've told you about is, so the probability of getting any repair, by the way, is getting 1 repair, or getting 2 repairs, or getting 3 or more repairs. So getting a repair of any type is 0.28. So therefore, no repairs would be 1 minus that, which is 0.72. So 72% of cars need no repairs during that first year. Okay, 72% of cars need no repair during that first year. Okay, how about this one? One car, and it needs no more than 1 repair. These always mess with my mind. Okay. No more than 1, so what's okay? 0 and 1 are okay. So my one car can have no repairs, or my one car can have 1 repair. So that's my 0.72 plus my 0.17. So there's 89% of cars will need no more than 1 repair. We actually kind of already had done part C. You could do it 2 ways. You could do it, some repairs means that you can do it like what we did up here in part A, where I said any repairs. You could do it that way. Now, I also kind of put in a little hint there. That means you get at least 1. And what have I tried to drill into you guys is at least 1. 1 minus the probability of no repairs. So that's 1 minus that 0.72, which is also 0.28. So either way you think of that, question C, you still are getting 0.28. All right, now this is where I'm going to leave you to start on your own, but I want to point out to you this question is now not just giving information for one vehicle. You are going to own 2 cars, and they have those same probabilities. So we have 2 events happening. You have information about a first car, and at the same time, something happening for that second car. So you have 2 events for each one of these questions. So you have that multiplication. All right, so I'm going to leave you on that. And again, your assignment is to get through page 11. and I'll come around and help you all class.